Okay, welcome back. Let's leave the relatively dull case of attached flow behind for a moment and go on to detached flow. Now, your book kind of just glibly says, hey, as the terrain gets steeper and steeper, something interesting happens to the flow. It separates. And here's an example of flow that has separated. See how there's like a terrain feature in this figure that I took from your book? And as the flow goes over it, that's actually a pretty steep cliff wall right there. And as the flow got steeper and steeper, all of a sudden we get this strange little separation in the flow where the flow at the surface is actually going in the opposite direction. See how like a little eddy has broken off? There's actually a right word for that. That's not really an eddy. The right word for that is a separation bubble. Separation bubble, by the way, is a very generic term for this. Separation bubbles happen on the cativating blades of a submarine's propeller and on the wingtips of aircraft and so on. I mean, just in general, when the flow around an obstacle breaks into this little eddy like that, that's called a separation bubble. Okay, I can't say I see that term very often in like a meteorological or energy type context, but that is the right term for such a thing. And the real key to noticing this feature is that all of a sudden your flow at the surface is going in the opposite direction of the general flow. That's really weird, but you can certainly see it by watching some videos and so on about how this works, and I happen to find this particular video really interesting. It's a very old demonstration of the flow, in this case over a wing. Now they have a cross-section of a wing here and they're illuminating the flow using some kind of smoke, and as they tip the wing at different angles here, you're seeing how the flow will be attached, and then as the wing gets steeper and steeper with respect to the flow, all of a sudden the flow separates and you get a detached flow. Overall, the flow becomes considerably slower when when it becomes detached, once it has separated from the underlying orography or the obstacle that it is flowing over, than if the flow had remained detached. It had remained attached. The flow will be faster if it can stay attached, whereas the flow will dramatically slow down if it becomes detached. It's part of the story of like how well, for example, an aircraft wing when it stalls. Okay, if the wing of an aircraft gets too pitched with respect to the flow flowing over it, suddenly the flow over it gets very slow and the wing doesn't generate lift anymore and the aircraft can crash if the pilot doesn't know how to recover from that. Really, the defining characteristic here is that the flow at the surface needs to be opposite the direction of the overall flow, and that has huge implications for wind power. Especially this business of how the wind speed will be so much less if the flow becomes detached. Lots of models are not very good at creating detached flow. In fact, lots of models can't create it at all, numerical models. So if you are trying to simulate what the flow is going to be over some location that you're thinking about making a wind farm, if your model can only make attached flow, it might think that place is pretty windy. Whereas if the real world, the flow often detaches, then you will have much slower flow at that location, which would have huge financial implications for your wind farm. Now, okay, I can picture this whole story of detached flow. I just don't know why yet it happens. Okay, I think we have to work through that. And that will be the main question that we address in part 3 of our lecture. But let's real quick talk about a couple quick questions. Question 3. When flow is detached, the wind at the surface is 0, parallel to the surrounding flat terrain, C, stronger than the winds at any other level in the atmosphere, or D, in the opposite direction of the overall flow. Which of those is what happens when the flow becomes quote-unquote detached? Make a choice from those 4 options and get a little feedback before you move on to question 4.